How can a seemingly small part cause a major helicopter incident? That's the question we're tackling today. Hi, I'm Devin. I'm a helicopter air ambulance pilot and welcome back to the channel. Whether you're a regular viewer or this is your first time here, I'm glad you're joining me. We're analyzing a Bell 407 accident that happened out in California near Mount Baldy. We're going to understand how a worn component, which was the throttle detent, contributed to this incident. We're going to analyze the NTSB report, its findings. By the end of this video, you'll gain a clearer understanding of the factors involved and how to prevent similar occurrences. Let's get started. All right, let's get into this non-fatal accident analysis of this Bell 407. Today is March 24th, 2025. So the purpose of this video is just to learn from this incident. We want to extract valuable lessons for pilots in the aviation community. This is something I always told my students when I was a flight instructor, and this is something I still do with all of my crews. We go and read accident reports, and we take what has happened to other pilots and other helicopters, and we learn from it. We want to be as safe as possible, so if we can learn from other incidents, then that's the best thing that we can do. All information presented in this is derived from official accident investigation reports. All of the information and references and resources will be on the last page and in the description below if you want to look at this. And then I want to say this, I am not an expert, but I want to share this information in the hope that it provides valuable insights and contributes to aviation safety. I don't know everything, not nearly, but we can all learn from this, and I just want to share this information so hopefully some of us, including myself, can learn from it. Let's get into it. So this was a Bell 407, registration number November 687 Alpha Mike. This happened in Mount Baldy, California on September 4th, 2022 at 7:57 local time. Now, interestingly, this was operated under Part 91. Even though this is a helicopter air ambulance, which is typically operated under FAA Part 135, this specific flight was operated under Part 91. That will make sense here in a moment. They were conducting flights to transport supplies and people. Like I said, it'll make sense here in a moment. Now the aircraft information. Like I said, this was a Bell 407. This specific aircraft was manufactured in 2001. The airframe, as of its last inspection, had 6,943 hours. The registered owner was Air Methods Corporation. The 407 has a max gross weight of 5,250 pounds, and it is powered by a single M250 C47 Bravo turboshaft engine. I love the 407. It is the best helicopter I've ever flown. That's one of the reasons I picked this story. I just love that helicopter. I think it's great. Talking about the pilot now, this aircraft on the day the incident was piloted by a 58-year-old male sitting in the right seat. He held a commercial and flight instructor rating. He also held his airplane single engine C rating. He had a second-class medical with waivers and limitations. They obviously did not specify what those specific waivers and limitations were. Now, he was a highly experienced pilot. He had 3,447 hours total in aircraft. He had 264 hours in this make and model. I'll just add a note for anyone that doesn't know. Asking if these are high numbers, these are really high flight hours. He had quite a bit of time. 3,400 is a lot of flight experience. 264 is plenty on this type. That doesn't strike me as a low amount. That's like plenty to have enough experience. He had 3,300 hours of pilot and command time across all aircraft, 28 hours in the last 90 days, 8 hours in the last 30 days, and 0 in the last 24 hours. Highly experienced pilot, highly recent, highly current, no questions. I think he was super competent from everything I can tell from this. Now, the meteorological information from this, the actual conditions at the accident site, it was VMC, visual flight conditions. The closest reporting facility to the accident was Kilo Charlie Charlie Bravo. So here, I'm going to zoom in here. Kilo Charlie Charlie Bravo right here is just northwest of Ontario International. What you're going to see here is there's two mountains that they kind of talk about here. They talk about Mount St. Antonio and Mount Baldy. So I'm not exactly sure which one it is. I'm not from the area, and it is a little bit weird. You're going to see on the next slide. But this is just northeast of the Los Angeles area in these high mountains. And so the actual distance from the accident site, this is 8 miles to the south, directly south, like 192 degrees south from the accident site. So pretty good weather reporting. Now the observation time that we got this one was from 8 8:15 local, which is about 15 to 20 minutes after the incident. Cloud conditions clear, lowest ceiling none, winds were not reported, wind direction, very calm day, precipitation and obscurations were not observed. Very good flying conditions, early morning, September, great Californian flight day. So the mission profile, according to the pilot, the helicopter was being used to shuttle people, water, and equipment in support of a local charity event between a lower landing zone at about 4,300 feet MSL and the summit of Mount Baldy about 4 miles away at 10,000 feet MSL. He estimated that he would need 5 flights to complete the mission. So this Twitter screenshot from the flight profile is from Daniel Firecopter. This is the aircraft that went down on Bell 407. So essentially what you'll see here is you have the lower LZ about 4 miles to the top of Mount St. Antonio. So he was doing these round trips, bringing people up. This is that Part 91, not helicopter air ambulance. They were doing like a charity event, helping people just using a helicopter. What you'll see here is this is a picture of Mount St. Antonio, very tall mountains. Now, I don't necessarily think altitude was a factor, in my opinion, in this incident, but very tall mountains here in the California range. So let's actually get into the accident. The pilot was conducting flights to transport supplies and people about 4 miles between a lower landing zone and a high landing zone. He was flying down canyon to lose altitude to set up for a steep approach to the lower LZ. As he was maneuvering and slowing the helicopter to land, a low rotor RPM warning occurred. He saw the rotor RPM was about 95%, which is low, and aborted the landing. He radioed ground personnel that he had a partial engine failure and was looking for a place to land. As he continued to fly down the canyon, he raised the collective and the low RPM warning occurred again. He attempted to land in a clearing but overshot it and landed in trees. As you can see, here are our trees. He said he did not check the throttle position during the event sequence, but he had maintained 100% main rotor RPM during each offload at the upper LZ. So take a moment. What do you think happened before if you haven't read the comments already, go leave your comments down below. Let me know what you think happened. Let's talk about it. So here is what went wrong. The data showed that during the 12 seconds before the fault, the power lever angle, PLA, readings were between 48 degrees and 50 degrees, and the engine was operating consistent with those settings. The normal PLA reading when the throttle is in the fly position is 70 degrees, and full engine governing is available down to 62 degrees PLA. So let me just quickly, before we jump into this, I want you to just know what we're talking about. The PLA, the power lever angle, is basically just the throttle position. And they're talking about the degrees of openness. So when the throttle is in the fly, so this is the 407, when the throttle is in the fly position, the PLA is typically between, the normal PLA reading when the throttle is in the fly position is 70 degrees, and full engine governing is available down to 62 degrees. So essentially what this is saying is because the PLA was between 48 and 50, this is well below the normal fly position, the throttle was not in the fly position. So at some point, the throttle on the collective moved out of the fly position. The pilot's operating handbook states that the throttle should be in the fly position for takeoffs and landings, and typically in cruise, I never pulled it out of the fly position. It also cautions that failure to position and maintain the throttle in the fly detent position during normal flight operations can limit available engine power. Obviously, normal fly, like that's where your engine wants to be. If it comes out of that, you're having less engine power. There is a detent in the throttle that is engaged by a ball plunger when the throttle is rolled to the fly position from either idle or max NG position. So you can be over towards idle on the left-hand side here, or you could be towards max NG. Basically what they're talking about, this plunger and this detent, is as you're rolling, if you're starting at idle and you roll to fly, once you get to fly, you're gonna feel like a click, like a pop, and there's like a detent. It feels like that. You can roll beyond that to max, and then when you come back to fly in this direction, you're gonna find that detent again. Here's it, the detent groove. So the throttle was manipulated So this is where it gets interesting. The throttle was manipulated by hand during post-accident examinations, and when the throttle was rolled from the fly position towards idle, like we're spooling down, there was perceivably less tactile resistance than when the throttle was rolled from fly to max NG. Testing of the throttle determined the ball plunger would disengage from the fly position detent when 4 pounds of the force was applied to turn the throttle. The helicopter maintenance manual states that 14 to 15 pounds of force should be required to move the throttle through the fly detent position. So this throttle was able to move with 4 pounds of force when it's supposed to be 14 to 15 pounds of force. Disassembly of the collective assembly revealed that the detent where the ball plunger in the throttle engages at the fly position was worn, which likely reduced the force required to move the throttle out of the fly position towards idle. No other pre-impact anomalies were found with the engine or airframe systems. So essentially what they're saying is this was probably the cause. What you see here is the detent. Now there is a lot of wear, less so on the max NG side, but a ton of wear on the idle. Obviously this makes sense. You're not typically rolling to max NG. I never did that when I flew the 407, but all the time you're rolling from fly to idle, fly to idle. So it makes sense that there was some wear. There was a lot of wear. I mean, this looks like a lot of wear, but how I know that this was significant is because 4 pounds of force was applied when the maintenance manual states that 14 to 15. You have like 1/3 the amount of force. It is able to move out of that fly position way too easy. So at some point, the throttle came out. This caused his low RPM. He thought he was having a partial engine failure, even though it was just the throttle. Incident outcome. So there was one crew injury, the pilot. He was seriously injured. Luckily, he was not fatally injured. No passenger injuries, just that one. Aircraft damage, substantial damage. I have to, and okay, let's talk about this first. Aircraft fires, none. Aircraft explosions, none. I have to say, yeah, it's a bad accident, but for the situation, I mean, he got it down, and like, if I have an incident or an accident, and this is what my helicopter looks like afterwards, I don't know, maybe it's a bad take, but I think like he did a pretty decent job. I think the helicopter's intact and he did a fine job. Let's talk about probable cause and findings. This is really interesting. The National Transportation Safety Board determines that the probable cause of this accident to be the pilot's failure to ensure the throttle was properly positioned before commencing an approach to land, which resulted in a low rotor RPM condition and impact with terrain. Contributing to the accident was a worn throttle detent. Are you kidding me? This is an interesting way to write this because contributing to the accident was a worn throttle detent. Yeah, I'd say that was a huge contributor. That they throw that in as the last line. Yes, did the pilot fail to ensure that the throttle was properly positioned? Yes, but also the throttle easily was able to move out of the fly detent. It was not at the right weight to be able to move. So it's just an interesting way to write. Now let's talk about this Air Assurance report. I love Air Assurance. I don't know if I'm pronouncing it right, but they just produce some phenomenal pieces of writing, accident investigations. They really go in depth here and they have like great narratives. This part is like really interesting. I'll link to this so you can read the full report down below. But significantly, testing of the throttle determined the ball plunger would disengage from the fly detent when 4 pounds of force was applied to turn the throttle. The helicopter maintenance manual states that 14 to 15 pounds of force should be required to move the throttle through the fly detent position. We talked about that. However, in a specialist report within the public docket, it also revealed that an exemplar throttle at the Bell Training Academy disengaged at only 5 pounds of force. There was a helicopter at the Bell Training Factory. This is like their flagship. This is where they do Bell training. And their helicopter, its throttle also disengaged at 5 pounds. What? If this is all true that it's supposed to be 14 to 15 pounds, how does your flagship, your training, your Bell helicopter at the Bell facility also only disengage at 5 pounds? Its throttle is worn, that detent is worn, the plunger. How does that, how? So here you can see table 1, friction force and torque results from accident 407, friction force results from Bell Training Academy 407. Idle to fly 4 pounds, fly to idle 5, and then fly to idle 4 pounds here. Unreal. How are they also 10 pounds underweighted, under-torqued, under-positioned? You know what I mean. How are you so far deficient in your factory aircraft? That's crazy to me. All right, let's jump into maintenance history. Maintenance records indicated that the throttle friction should have been verified per the manufacturer's inspection schedule. The procedures directed maintenance personnel to set throttle friction by adjusting the ball plunger. It could not be determined if maintenance personnel did not properly adjust the ball plunger or if the worn detent reduced the ability of the ball plunger to maintain the correct torque after being set properly. The maintenance procedures did not require inspection of the throttle detent. If the specified throttle friction forces were unable to be achieved during inspection, this should have provided an opportunity to identify and correct the worn throttle detent. Of course, so this should have been caught if they did the maintenance procedures correctly. This should have been caught. Emergency response. Let's get into this. Let's have a little bit of conversation about what happened. What went right? The pilot safely got the helicopter to the ground. At the end of the day, this is all that matters. If you safely are able to live after a helicopter comes to the ground and not the right way, you did a good job. The pilot stayed alive. He made a mayday call. He let his crew, he communicated, I think it was with the ground personnel, that he had an engine failure and he was continuing down. He found a suitable landing area. Now, they did say he kind of missed a suitable landing area, but I'd say, I mean, even like getting on this path here, is it like the best option? No, but I mean, when I think about if I'm going to have an incident, I want to get somewhere like easily accessible, and he got it down onto this path, onto this road where cars and ambulances and fire trucks could easily get to him. So I would say like overall like a pretty decent job. What could have been done differently? We're going to dive into this a little bit. Maintenance inspection, they hopefully should have found this. They should have found this. And the pilot response. Now, I am totally armchair quarterbacking this, and I don't know what I would do in this situation. I don't know that I would have done it any differently. I hope that I would have responded a little bit differently, but I'm not making fun of this pilot. I'm not saying he did anything wrong. We're just talking about like now that I can sit back 20/20 vision in my house, be all chill, I can say what he should have done differently, but no one knows how they're going to respond in this situation. But the proper procedure, obviously in this situation, would have been to lower collective and roll on throttle. He lowered the collective, but if he had rolled on the throttle, this would have alleviated the problem. Here's the training focus. If you're a student pilot or if you're coming up in the industry, training focus, low rotor RPM, practice, practice, practice. This, I'm like, for me, this was like a huge thing in flight school, and this was a huge thing as I was a flight instructor. As a student, my instructors did this to me constantly. In turn, I would do this constantly to my students when safe. What am I saying here is we would always practice low rotor RPM. As soon as like I was in my private, as soon as I could like hold onto the helicopter pretty well, they had taught me about low rotor RPM, I would just be flying along. My instructor would be like, all right, Devin, let's go over there, let's do this. As I'm en route and I'm like just focused on the helicopter, like trying not to do anything weird, RPM would start to drop. And I'm like, what? And then I lower collective roll on. And then he would do this all day, every single flight, my instructor would do this. All my instructors would do this, would be doing something on an instrument approach. RPM comes out, lower collective roll on. And it just like was muscle memory for me. Lower collective roll on, lower collective roll on, lower collective roll on. And then when I was a flight instructor, I would do this to my students. They would be in cruise somewhere, lower collective roll on. I wouldn't really do it in anywhere that's like a dangerous area because you don't want them to think it's an engine failure and just like dump collective and like try to do an auto rotation. But as we were in cruise, I would just slowly just work that RPM down, 101, 100, 99, 98. I think in the Robinson it comes on at 97, the low rotor RPM horn. I haven't flown in years. I hope I'm right, but I would just play with it just so that they get into the habit. Like, no, you gotta scan your instruments. You should see it happening. And by the time like students got to like the commercial level, they would identify. You can hear it. You can feel the little yaw change. Like from 101 to 99, you can feel a little bit of you can hear a little. Maybe that's dramatic. It's like you can hear it. So I would get like really tuned in on this. So I would teach my students this happened to me. So you would always know lower collective roll on. If it's an engine failure, okay, you do your auto rotation, but you're already starting to fix the problem by lowering collective because you're taking the pitch out of the blades, which is going to allow the RPMs to spool up a little bit faster. So lower and roll on, lower and roll on, lower and roll on. That's the training focus. That's like the big takeaway I would have to say that how this incident could be avoided. proper training could have been avoided. But we need to talk about the key takeaways. Proper throttle positioning is crucial for maintaining adequate rotor RPM and preventing loss of control. It is, talking back about the Robinson, you do have that governor there that comes on above 80%, and it's just fighting to keep that throttle in the 102. I think 102, is it 102 or 110? Oh, I think it might be 110. I'm sorry, it's been a while, and I've got multiple helicopters in mind that I think about, but that governor is constantly fighting to keep those RPMs up. In turbine helicopters, you don't have that. That's just not a feature. So you have to manually be thinking about this and watching this. Now you do have that detent, which should hold your throttle there, but you need to make sure that your RPM is staying in the green. Wear on critical components such as the throttle detent can significantly impact aircraft operation and should be addressed through diligent maintenance practices. This is a given. Maintenance should have found this and should have fixed this. This should not have been allowed to get to that point. Pilots must be vigilant in recognizing and responding to low rotor RPM warnings. So there's a couple things here. Now, I love the 407 and this is great, but in terms of first warnings for this specific situation, so let's talk about what actually happened. At some point, the throttle did come out of fly because he was up top and then he came down. They said as he was slowing down, if you remember the first narrative, the pilot was conducting flights as he was flying down canyon to lose altitude and set up for a steep approach to the lower LZ. As he was maneuvering and slowing down the helicopter to land, a low rotor RPM warning occurred. So, at some point the throttle did come out of fly. We've established that. What caused that throttle to come out of fly? I mean, could he have been like aft cycling, trying to slow down? He's got this steep approach they talked about. Did he slowly just roll that throttle out? And obviously there was not enough force on that throttle to hold it there, but what actually caused the throttle to come out? So you want to be very careful when you're flying, and I've had this happen before, but you got to be very careful to just make sure you're not holding that throttle. Let's see here. But as I was talking about, in terms of first indications, on the 407, the first indication you have is that low rotor RPM warning horn. When your RPM gets low enough, you're going to get that low RPM warning horn, and it's going to tell you, hey, fix your RPMs, like there's a problem over here. So is that the best indication for a problem? No. So I fly the AW119 now as my primary helicopter. This is a helicopter air ambulance that I fly. Now we have a PLA pause caution light, power lever angle position caution light. So when you are at any position lower than the fly detent, it will illuminate a caution light. So when you're doing your startup, your run up, it says PLA pause. As soon as you advance the throttle to fly, we also have a detent where you can feel it click in, it goes, and you know you're in fly. PLA pause goes out as a caution light. So before you do your takeoff, and this is something everyone has their things, and I still remember, check PLA pause. So PLA pause, make sure that you are in fly, and it's relatively clear because if you're not in PLA pause, you see that caution light, and part of my scan, like right before I take off, I try to look and make sure that no caution lights. So PLA pause. So it would be better if the 407 and maybe the newest versions, maybe like the GXI, maybe they have a PLA pause caution light, but the 407s I was flying did not have a PLA pause caution light, which would have helped the pilot in this situation. And if you eventually do get to the low RPM warning horn point where like your RPMs are dropping and it says low RPM, if on that caution light, if it also says PLA pause, then that's a dead giveaway. Okay, like low rotor RPM plus PLA pause, or you have two low rotor RPM PLA pause. Okay, instantly I'm like, oh, PLA pause, PLA pause, PLA pause. So you know it's the throttle. PLA pause I've attached in my brain to throttle. There's just no difference in my brain now. So that would have been something that could have helped. All right, before I keep ranting too much, my thoughts. Super unfortunate incident. Any incident in an aircraft is extremely unfortunate. Like I said, I don't want to armchair quarterback, but there are things we can obviously learn. Pilot responded well to what he thought was happening. He thought he had a partial engine failure. Interesting in the moment. I mean, I've never experienced a full engine failure or partial engine failure, so you don't know exactly what it's going to feel like or what you think is going to happen. And it's interesting because he like lowered collective and then he tried to raise it again and the RPMs kept dropping. So he thought it was a partial engine failure. Okay, so you're going to make and at least he didn't auto rotate. This is one thing I teach my students is like, if you think you have a partial engine failure, don't just dump the collective. If you still have engine power, ride that as long as you can. Like, ride that collective until your RPM start to drop. Use that engine power while you can. Like, yes, we are all cool, we can all auto rotate, like, no, if you have an engine, use that engine to your advantage as much as you can. So he thought he had a partial engine failure. He continued. He let people know he was going down. Proper indication would have prevented this. We talked about that. PLA pause, caution light could have prevented this. The proper response would have been to fix the proper response would have fixed the problem. Lower collective and roll on. Lower collective and roll on would have fixed the problem. I don't want to armchair quarterback, but it's just, that would have fixed the problem. Proper maintenance could have also potentially found the problem. They should have, if they followed all their maintenance steps, and maybe they did, I'm not exactly sure, but this one clearly fell through the cracks. Swiss cheese model, accident. If you talk about the chains, this was a chain and something broke, and if the maintenance had found the problem, then this wouldn't have happened. Alright, so here are all the references if you are curious. NTSB accident number, registration, 687 Alpha Mike, the full NTSB report down below, Aviation Safety Network, I pulled some information from them, Air Assurance, great website, they've got great write-ups, and then a couple Twitter, X resources, Daniel Firecopter and Air Assurance. Alright, so there you go, a Bell 407 accident case study. Really interesting, non-fatal, that was important, and I'm glad the pilot walked away from this. Really kind of an interesting situation that we don't get to discuss that much. It wasn't like an IMC wire strike, it was kind of an interesting one. I flew the 407, I know this helicopter. I had times where I didn't get that throttle directly to fly, and you know, if you don't, that can cause real problems. But this one was really interesting because the wear on that throttle detent caused it to come out a little bit earlier. Now, something did happen. I mean, maybe he just like leaned a little bit. And that's why they had built that in as 14 or 15 pounds. So that little nudge shouldn't have happened. But I mean, who knows if it would have happened if this was properly tightened to the right torque setting. But it makes me, I believe that probably if it was actually torqued to 14 or 15 pounds, it wouldn't have. It was also interesting what Air Assurance said, that the Bell helicopter that they went and looked at also came out at the wrong weight. So that is wild to me. So really interesting accident, really interesting incident. Let me know your thoughts down below. What do you think the pilot could have done differently? What are your thoughts on the Bell 407 and this throttle position? What do you think about the PLA pause? How do you teach your students, or if you're a student, what has your instructor taught you about low rotor RPM recovery? Lower and roll on. That's all that's in my head. Lower and roll on. I hope if this situation ever actually did happen, I would respond correctly. But those are my thoughts. I want to hear yours. Let me know down in the comments below. If you found yourself enjoying this video, smash the like button, subscribe for all kinds of helicopter content, and I will see you on the next one. Take care.